Yes.
Hey, what do you mean by a self-paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way.
Oh, yes, way. Don't. Hi.
Oi, so they give access to their job portal, Geeks for Geeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way.
Oh, yes, Wiz. Don't delay. Enroll now.
Geeks learning together.
Hello and welcome back to this amazing channel Geeks for Geeks, and this is Abhinav. In this particular video we are back with the new problem of the day. So we have done a problem study which was maximize XOR, and today the problem is GCD array. Okay, it is another interesting problem for today. We will be solving this problem live in this particular session. So first of all, please let me know if I'm clearly audible and visible to you all so that we can continue with the problem. Just please let me know if I'm clearly audible and visible to you all. Okay, okay, great. Thanks, Rishit. Hi, Rishit. Hi, Naked. Hello, everyone. Let me share the screen and then we will start. So, great. Guys, you can see the problem. The problem is that you are given with an array, okay, ARR of length n, and you are also given with an integer k. So basically, the thing is that you have to divide that array into k parts, okay, such that uh, the sum of each part, the sum of each subarray is you have to calculate, and then hi Pritam, hi, and then you have to find the GCD of all the separate sums, and then that GCD value should be maximum. So it's like a next level problem. It's a good problem actually. So and we will be using a different concepts to solve this problem. There will be different concepts that will be used to solve this problem basically. Okay. Okay. Sorry. So okay. So see guys, let's take a problem. Let's take an example. Okay, 6, 7, 5, 27 and 3. Okay. Let's say this is the example and the value of k is 4. So the value of k was 4, and like we have to divide that code, this array into 4 parts, okay, and such that it has the maximum GCD. It has the maximum GCD. Okay. So first of all, guys, the first logic that comes in our mind is key that there like we have to divide the whole sum, the whole array, the whole sum of the array into k different parts, and that part should have a GCD. That all the parts should have a GCD. GCD means they all should have a common factor. Am I right? GCD means they all, like if I'm talking about the GCD of 6, 12 and 26, so it's 3. Why 3? Because 3 is the common factor of all. Am I right? So if I'm finding the GCD of these three values, it's nothing but 3. Because 3 is the greatest common divisor, or you can say the greatest common factor, HCF, highest common factor. So we have to find for the common factor. Is this much clear? Okay, great. Now, if I'm saying that you have a sum, you have to divide that sum into k parts. Okay, and then each k part should have a common divisor, and that common divisor, that common factor should be the highest common. ये तो निकालना है. We have to find the maximum GCD. Okay, so let's see how we can do this. Okay, first of all, what we will do? First of all, we will check for all the possible values of GCD. First of all, we'll find all the values of GCD which are possible. So, like, we will find the whole sum, the sum of the array, and then we will find how many factors are there of that sum. Like, tell me, maybe it is quite confusing. Tell me the sum of this array. What is the sum of this array? So the sum of this array is nothing but 10, 37, and 42 and 48. The sum is 48. Am I right? The sum is 48. Great. So it's fine. Now, guys, find factors of 48. So one factor is 1, obviously. 1 or 48 is the factor. Then we have 2 and 24. Then we have 3, yeah, prefix sum concept. 3 and 16. Then we have 4 and 12. Then we have 6 and 8. 8, 6 are 48. These are all the factors of 48. Am I right? These are the factors of 48. Am I right? Okay. Great. Now, guys, please find the prefix sum. It will be 6 and 13, 18, 45 and 48. Okay. Now we will have a hit and try. So firstly, our answer is always 1. 1 is the always possible answer. 1 is always a possible answer because maximum GCD can be 1. एक से छोटा GCD हो ही नहीं सकता ना. So 1 is the always possible answer that we can have. Now, we'll check for 2. That whether we can have 4 different arrays, 4 different parts in that array which are having 2 as the factor. Because if all the 4 parts are having 2 as the factor, that means we can have a common GCD of 2. So how we can see? So the first part of this prefix sum is 6. So is 2 the factor of 6? Is 2 the factor of 6? Yes, it is a factor of 6. Means this part of the array has a factor 2 till here. Okay, then let's move forward. Is 2 the factor of 13? No, it's not the factor of 13. That means it cannot also be the factor of this part. Because 16, if it's not of 13, then it's also not of 13 minus 6. Is it the factor of 18? Yes, it is the factor of 18. And it was also the factor of 6. So means it will also be the factor of the middle element, which is 12. So now we have got 2 different subarrays which are having factor 2. We have got 2 different subarrays. Now, is 48 a factor of 2? No. 48 is not the factor of 2. Fine. Great. Move forward. Sorry, 45, not 40, 45. Okay. Now, is 48 the factor of 2? Yes, 48 is the factor of 2. So means we have got the third subarray, which is a factor of 2. And then we have ended. So how many subarrays are there which are the factor of 2? How many subarrays are there? There are 3 subarrays which are continuous subarrays. But how many subarrays we are targeting? We are targeting n as 4. K is 4. Sorry. So it is not possible. So means for answer 2 it's not possible. Is it clear? ठीक है. Now let's check for next. Next is 3. Now let's check for 3. Is 6 a multiple of 3? Yes, it is a multiple of 3. Means this subarray can has a factor 3. Okay, now is 13 a multiple of 3? No, 13 is not a multiple of 3. Now, is 18 a multiple of 3? I don't think that factor like this is required this necklace. You can use obviously, but I don't think no we can't use. I think I'm not sure about that. We cannot use. We have to iterate for all the devices. Yeah, for all the devices. Okay. Now the next one. Okay. Next is this is also a factor of 3. Now, is 45 a factor of 3? Yes, 45 is also a factor of 3. And then 48 is also a factor of 3. Now, here we have got 4 subarrays, and that is our answer. So, guys, this is how we will do. Okay. So, first of all, what I will do is, first of all, find the sum. So, I will take our sum here, int, and please take this value as small k and small n. And please find a sum. Let's take the sum as long. Not sure if initially as 0. Now for the numbers, I will add the sum. Okay. Now I will take a vector. It will have factors. Let's say f. And for factors, guys, we will start with 1, and we basically go up to the square root of sum. I hope everyone knows how we can find factor. And then we will push first of all I. If I is so, first of all, we will only push it if I or if sum mod I is equal to 0, then only we will push it. And if sum divided by I is not equal to I, factor having factor, we will push sum by I also. Okay, so that it should not be repeated. Now for each factor, like initially we will take our answer as 1. Thanks, Rishit. Initially our answer will be 1. Okay, now it is saying in I is equal to 0, I is less than f dot size, like all the factors I plus plus. And we can say that we will check from the back side. Why back side? Because first of all we'll check for the maximum. Na? We have to maximize the factor. So एक काम करो कि solve this vector first and then reverse it so that the maximum factor should come first. Okay. Now, for each factor, what we will do? I will check through the. Okay. We have to also do one more thing. One more thing is we have to find the this prefix array. So I will use the same array to store the prefix array. I will use the same array to store the prefix array because the array is not. Okay. Now if so now here we will take for in j is equal to 0, j is less than n, j plus plus, and if take a count here, if ARR of j mod I, sorry, mod f of I is equal to 0, means just like we're checking na, ki if the value of prefix sum was the multiple of that factor for which we are checking, increase c, increase c, and if c becomes greater than or equal to k, to return c. If c becomes greater than or equal to, return c, otherwise simply return 1, which is the answer. So for this, it's sorry, return C nahi, return f of I. Sorry, return f of I. Like that factor for which it's running fine. Okay. Okay. Got the right answer. It got the right answer. And if we talk about the like the time and space complex, you can see here also x is the number of factors of the element. So it is same like time complex is n into x and space complex is order of x, that vector that we are taking. This is the expected, this is the time and space complexity for this particular program. So we have solved in the expected time. Okay. Yeah, let me check the comments. I've just missed the comments. Uh, if it is possible, then go left side. It's not possible, then go right side. But I don't think it's right, is it? When checking mod, why are we not subtracting the value of the previous found group? No, not because see this it, see this it. What we will do is that let's say keep this current. देखो, if the previous one is the factor of, if the previous one is the factor, and this is also a factor, so obviously value between this will be a factor. So मैं check करने की जरूरत, there is no need to check. Getting? If previous one is also a factor, this one is also a factor, so their subtraction, their difference will also be a factor. You can check in all the cases. Got it? Is it clear? Okay, Arvind, I'm explaining again. Just a minute. I'm explaining it again, okay? Arvind, are you there? Okay. Just the code. Okay. Let me explain it. So first of all, we have taken a sum. Okay. After that, we have taken a factor where we are storing all the factors of the that sum. Okay. So see, this is the loop which is starting from 1 up to the square root of f, square root of sum, and we are storing the factor. So like if I is the factor, store it, and also it's like let's say if we talk about 48, So for 48, 3 is also a factor. So sorry guys. Yeah, it was freezed. Is it clear now? Clear? Okay, okay, yeah. No videos. Okay, yeah, I think it's fine now. So see, like so now we have the factors in that f. Okay, now we are sorting the factor in the decreasing order, like sorting and then reversing, so that we have the maximum factor at the start because we want the maximum GCD ना. So लोग maximum factor पहले देखेंगे. Okay. अब देखो, for that factor we will check at each point of the prefix array कि if that particular segment of the prefix array or that array is a multiple of that factor or not. Okay, and if there are more than like greater than or equal to k such multiples, but by the way it will be equal to k only, we will simply return it. We will simply return it. So this is the thing. You can like again like for the logical part, you can again check out the like back of the description part when I'm explaining. Okay, is it clear, guys? Now is it clear somehow? Maybe there is some like network issue from my side here. Arvind, all of you, Rohit, Kavita. Okay, okay, great then. Great guys, you can like check out the approach again. Okay, and thanks, Tanisk, thanks. Great. So thank guys, thank you for watching this particular live. I hope you have, but I didn't think of the approach. It's fine, Nakaj. It's fine. Like it was a difficult one. I know, it was like the most optimized one. So even I have taken the hint. So don't worry. Just thank you guys. Thank you for watching this particular live. I hope that you have learned something new in this particular live, and let's meet again in the next weekend, next Saturday, maybe before that. Okay, for the next problem of the day. Till then, happy coding. Happy coding. Uh, Keep coding, keep practicing on Geeks for Geeks, and just try to learn new things. Okay. Uh, Good night. Good day for tomorrow. जेब जी कर लो, हो जाएगा.